So today we are going to discuss Coulomb's law. Uh, Coulomb's, in the last class we have discussed that if the charged body is separated by a distance, okay, if the distance is very large compared to the size of the body, okay, so the size of the body is very small compared to the distance, then the charged bodies are called point charges. So Coulombs measured the force between two point charges and found that it varies inversely as a square of distance between the charges and was directly proportional to the product of magnitude of two charges and acted along the line joining the two charges. This is the definition of Coulomb's law. You should by heart it. What is that? The Coulomb's, the force, whatever force here you see this equation, the force will be directly proportional to the product of the charges. Say here we have taken two charges, Q1 and Q2. Okay, so these two charges are separated by the distance r. Okay, so what is Coulomb's measure? The force between these two point charges, and it is found that this force, whatever force we are finding, is varies inversely as the square of the distance between the charges. So what is the distance between the charges here? Is r, no? The distance between the charges is r. Okay, so f is inversely proportional to the square of the distance. So it is 1 by r. F is proportional to 1 by r. Okay, and what they have given and is directly proportional to the product of magnitude of two charges. So what are the two charges we have taken here? See, the two charges are Q1 and Q2. So the force is directly proportional to Q1 and Q2. Okay. So the force will be acting in the line joining of two charges. So what is the line? Because here we are taking two charges, no? We are taking two charges here. Say here, this is Q1 and this is Q2. These are the two charges. Okay. So if you are finding what is the force between, say the what is force acting on Q2 due to Q1. Okay. So the line joining. So from what is the distance here? Uh, the point 2 minus point 1 will give you the distance. Okay. So in this line, the force will be acting in the same line. Okay. So what is that here? We are finding the force on Q2 due to Q1. So the force will also be acting in the same direction. What is the direction here? It will be acted along line joining the two charges. So how, which is the, in this direction, in which direction these two charges are connected, in that line joining only the force will be acting. Okay. Okay. So this is about Coulomb's law. So what we have taken? We have taken two charges Q1 and Q2 separated by a distance r. And you have to remember that here we will be discussing that these two charges will be placed in the vacuum only. It is not placed in any other location. It will be placed in a vacuum. Okay. So in that case, F will be equal to, it is proportional, no? To remove proportionality, we will be multiplying with some constant. Here K is a constant, and we have discussed that force will be directly proportional to the product of these two charges and inversely proportional to the square of distance between the charges. Okay. So what is the distance between the charges is r. So it is F is equal to K into Q1 Q2 divided by R square. Suppose the charge. So here how the Coulomb found this formula and all is discussed. Okay, anyway that is not important. This point may be important for your NEET exam or JEE exam. That is why we will be discussing this point. Suppose the charge on a metallic sphere is Q. Okay, we are taking a metallic sphere. What is the charge on metallic sphere is Q. Okay, if the sphere is put in contact with the identically uncharged sphere. Means we are taking two spheres. One sphere is having charge q, another sphere is uncharged, but it is having same what is that identical sphere we are taking. Okay, so the charge will be spread over two spheres. So if you put in contact, what happens? The charge, the charge on first sphere will be spread to the second sphere. Okay. So by symmetry, the charge on each sphere will be what? Q by 2. So what we have, what is the total charge is Q. Now this is spread between two charges, two spheres. This Q is spread between two spheres. So each sphere now will have Q by 2. So one first sphere will have Q by 2, second sphere will have Q by 2. If you add both, what is that finally you get? Q. Okay, that is called law of conservation. Charge neither will be created nor will be destroyed. The charge will be distributed. So if you find out what is the total charge will be Q only. So repeating this process, we get similarly if you take two more spheres, then the total charge will be Q by 4. So four spheres we have, no? The total charge will be Q by 4 on each sphere, like that we will be getting. So this is by symmetry we will be getting like this. Okay. So here and now they will explain how Coulomb find this formula and all. Okay, anyway that is not important. So in this equation 1 we have discussed. What is equation 1? F is equal to, here I'll show you equation 1. F is equal to k into q1 q2 divided by r square is the equation 1. Okay. So in the equation 1, k is so far arbitrary. So we can choose any positive value for k. Okay. So the choice of k, however, which value we take for k, determines the size of unit of charge. What is the size of unit of charge? Okay. So this may be important bit. What is the choice of k? The choice of k determines the size of unit of charge. In SI unit, the value of k is, what is the value of k will be 9 into 10 power 9. This is the value you get. The unit of charge that result from this choice is called a Coulomb. Okay. So if you take k is equal to this value, what happens? We will get 1 Coulomb value. Depending on k, we get the unit of the size of unit of charge. Okay. If k will be chosen like this, 9 into 10 power 9, the unit of charge will be 1 Coulomb. Okay. So from this only we get the definition for Coulomb. Okay. So in the equation 1.1, that is what F is equal to k into q1 q2 divided by r square. In that equation, if you take q1 is equal to q2 is equal to 1 coulomb, r is equal to 1 meter, what is the force we got? It is 9 into 10 power 9 newtons. Okay, that is, what is 1 coulomb? 1 coulomb is the charge that when placed at a distance of 1 meter. Okay, so we are having two charges. What is the charge on 2 point charges will be 1 coulomb, which are placed at a distance. What is the separation between these two charges is 1 meter from another charge of same magnitude in vacuum. Here we see that this is the formula we are using for finding the charge between the two point charges in vacuum. Okay, experience a electronic force of repulsion of magnitude. What is the magnitude? 9 into 10 power 9 newtons. Okay, because what is the k value now? K is 9 into 10 power 9. Here, see, F is equal to k value we have substituted. Q1, Q2 is also 1, R is also 1. Okay, finally we are getting 1 here. So finally F is equal to 9 into 10 power 9. We left with 9 into 10 power 9. So here we are taking two same charges, Q1 and Q2 are having positive charge. Okay, since we are getting, so we have discussed that if you have same like charges, if you have like charges, we'll be having repulsion. If you have unlike charges, means one is positive and other is negative. If you have unlike charges, then we'll be getting attraction. Okay, so that is why we will be getting repulsion of magnitude. What is the magnitude in this case is 9 into 10 power 9 newtons. Okay, so this is very large. 1 Newton, 1 Coulomb is very large. That is why whenever we are discussing in electrostatic, we have to use very small values like 1 millicoulomb or 1 microcoulomb like that. So the constant K in the equation is usually put as, what is the constant K value will be 1 by uh, 4 pi epsilon naught. Okay, so Coulomb's law now we will write K will be replaced with 1 by 4 pi epsilon naught into mod magnitude. Okay, so if you have, what happens magnitude, if you take either it is positive or negative, if you take mod, what happens, we will be getting positive only. So if say Q1 is positive, Q3 is negative. If you multiply these two, what happens, you will be getting negative value. So if you take mod, what happens here, we will be getting positive only. Divided by r square is the distance between them. Okay, so we will be calling it as force of attraction or force of repulsion depending upon the type of charges. If you have like charges, we will be calling it as force of repulsion. If you have unlike charges, we will be calling it as force of attraction. Okay, so what is epsilon naught is called permittivity of free space. Okay, the value of epsilon naught in SI units will be, this is the formula for epsilon, value for epsilon naught, you should remember this. If you substitute 8.854 into 10 power minus 12 Coulomb square per Newton meter square. Okay, so if you find out, if you substitute epsilon here, multiply with 1 by 4 pi, take reciprocal, you get the same value. What is the value we get is 9 into 10 power 9. Okay, so either you can remember this complete value as 9 into 10 power 9. So if anybody is asked for Coulomb's law equation, Coulomb's law, we should write same equation. Here, whatever equation we are discussing, no, this equation only you should write. That is F is equal to 1 by 4 pi epsilon naught mod Q1 Q2 by R square. And you should write Q naught is permittivity, and you should write what, sorry, epsilon naught is permittivity of free space, and you should write what is epsilon naught value also. Okay, so since here the force is a vector, okay, so that is why it is better to write the Coulomb's law in vector notation. Okay, so let the position vectors of charges Q1 Q2 are Q1 Q2 B. What is Q1 is placed, say here it is origin, see this figure, this is origin. From with respect to origin, Q1 is placed at a distance R1, Q2 is placed at a distance R2. Okay, so with respect to origin, we are taking from origin where your Q1 is placed, where is your Q2 is placed. Okay, so let the position vectors of charges Q1 and Q2 will be R1 and R2. This is called position vector. So this gives you the direction and where it is placed. Okay, and we denote the force on Q1. Force on Q1 due to Q2. So we have two types of forces. The force on Q1 due to Q2 or force on Q2 due to Q1. Okay. So if we are finding what is the force on Q1 due to Q2, then that force we denote with what? F12. So one is there, no? This indicates that we are finding force on Q1 due to Q2. Okay. And here also F21, 2 indicates what? We are finding force on Q2 due to the second charge. What is second charge is at position 1. Okay. So see here we denote force on Q1 due to Q2 will be F12. The force on Q2 due to Q1 will be F21. The 2 point charges Q1 and Q2 have been numbered. Now how we are numbering it as 1 and 2 for convenience. Vector leading from Q1 to Q2 is denoted by C. What is the vector leading from 1 to 2? Denoted by R to 1. What is R to 1? So from position 2 minus position 1. See R21. What is this indicate? Where the first index here, not 2. 2 is the position here, R2 minus R1. Okay. So say if you have R12, then what is that indicates? R12, R1 minus R2. What is the R21? This is leading from 1 to 2. Means say for example, you take, okay, say if you want to find out what is the distance between, say I take it as 5, this as 5, this as 7. Okay, what is the distance between 5 to 7? Means what? 7 minus 5. 7 minus 5 will give you what is the distance between these two. Same way, say what is the direction here? It is from 1 to 2. The direction is 1 to 2. So to find out the vector from 1 to 2, what you have to do? The second point minus first point will give you what is the distance between these two. Similarly, here also, you see here, it is from this point to this point. Okay, so you have to find out second point minus first point will give you this vector. Okay, oh, so what is that here? Um, so R21 is the vector from 1 to 2. So in the same way, the vector leading from 2 to 1 is denoted with R12. So what is R12? R1 minus R2. Okay. So these two will have the same magnitude, but direction will be different. See here, if you see this second figure, see this second figure, R21 is from 1 to 2. R12 is from 2 to 1. Okay, the distance between these two will be same, but direction will be different. Whereas this will have this direction, R12 will have opposite direction. Okay, so that is why these two will be same, but R12 will be equal to minus R21. The magnitude of these two vectors R21 and R12 is denoted by R21 and R12 respectively. We are taking magnitude. What is magnitude? If you take magnitude, either it is positive or negative, it will be considered as positive only. Magnitude will be always positive. Okay, so R12 will be R21. So if you have negative sign means the direction. Negative means the direction here. Okay, magnitude will be positive. Depending on direction, we will be having different signs. The direction of a vector is specified by the unit vector along the vector. Okay, to denote the direction from 1 to 2 or from 2 to 1. So we define unit vector. What is unit vector? Unit vector we denote with cap. Here you see you don't have any cap here. This is just vector. Unit vector is we denote with a cap here. Okay. So what is the formula for unit vector is R21 divided by the magnitude of R21 will give you the unit vector in that direction. If you want to find out what is unit vector in this direction, so what is the vector divided by its magnitude? That gives you unit vector. Okay. So the Coulomb force law between 2 point charges Q1 and Q2 at R1 and R2 is denoted by. See here we have unit vector also. Before you don't have unit vector. No? Now it is having direction also. In which direction it is acting? In the direction of line joining between these two charges. So we are finding that what is that? We are finding force on charge 2 due to charge 1. Okay. So the line joining from 1 to 2. So it is from 2 to 1. Okay. So what is that here? See here the broad R. Broad R indicates the vector. There is, if you don't bold it, if you don't bold it, it will give you magnitude. So here we have to take magnitude. Q1 Q2 divided by what is the distance between those two charges. That is the magnitude you have to consider in the denominator. Into, see here it is bold here. Bold and cap also you have. This indicates unit vector. Okay. How do you find out unit vector? The vector divided by the magnitude of the vector. That gives you the unit vector along that direction. Okay. Similarly, if you want to find out F12, how do you do? Wherever we have 2, 1, we have to replace 1, 2. Here also we get 1, 2. Here also we get 1, 2. So what is F12? F12 is nothing but the force on charge 1 due to charge 2. Okay. So here we have some remarks from this equation. Just discuss that. Okay. So equation is valid for any sign of Q1 and Q2, whether it is positive or negative, whichever, because we are taking magnitude. No, I told you. If you take magnitude, if it is positive or negative, it becomes positive only. So the same equation is valid for any sign, whether it is positive or negative. Okay. So if Q1 and Q2 are same sign, so both are having positive sign or both are having negative sign. Okay. So what is F1, F21 is along the unit vector cap. If you have cap indicate it is a unit vector R21 which denotes repulsion because these are like charges. No, the force between like charges is repulsive force. So it is called repulsion as it should be for like charges, like charges. If an Q1 and Q2 are opposite signs, say if Q1 is positive and Q2 is negative, in that case F21 will be denoted as minus R21 because one is positive, another is negative. No? So it becomes, what is it becomes? Minus R21 will be equal to what? R12. Here we have this denotation. See here, R12 is equal to minus R21. So minus R21 will be equal to what? R12. See this figure? What is R12? See here, if these two are having same charge, the force will be, here you see first figure, the force will be in opposite directions because it has repulsive force. If it is attractive force, the force will be towards, the direction will be same, towards each other. It is opposite to each other. Okay, because here we have taken like charges, here we have taken unlike charges. Okay, so denotes attraction as expected for unlike charges. Okay, so that is why here we don't need no need to write separate equation for like charges and unlike charges. Same equation holds good for both cases. Okay. Similarly, the force F12. What is F12? The force on charge Q1 due to Q2 is denoted by same formula. No? Here what you have to do, wherever you have 2 1, replace with 1 2. Interchange 1 and 2. You get this. What is this? It is just negative of F21. F21. Because what is R12? See this figure? R12 will be equal to minus R21. And magnitude of R12 and R21 will be same. Okay. So because of that, what is this? It will be equal to minus F21. Okay, so F12 will be equal to what? Minus F2. Okay, so Coulomb's law agrees with the Newton's third law. So you know what is Newton's third law? No? Coulomb's law is also agreed with the Newton's third law. Okay, so Coulomb's law gives the force between two charges and Q1 and Q2 in vacuum only. Okay, it will give force between two charges in vacuum. Okay. If the charges are placed in a matter or intervening space has matter, the situation gets complicated due to the presence of charged constituents of the matter. So in that case, you should not consider epsilon naught. Okay, we have to consider what is permittivity of that particular matter. Okay, that is why it becomes more complicated. That is why you should remember that Coulomb's law, whatever equation we have discussed here, that is used to find out the force between two charges Q1 and Q2 in vacuum only. Okay. So with this we have completed Coulomb's law. Okay. If you have any doubts or any if you want to discuss anything, you just put it in comment.